Howdy, AP PreCal. It's Miss Kosh. Today we're going to start with the 2.7 and 2.8 notes. We're dealing with operations of functions and composition of functions, and then inverses of functions and all that kind of stuff. The notes that we put together are ridiculously long. So what I'm going to do for you is I made the font red on the problems that I'm not actually going to teach, but my answer key that I'll post will have is already finished and it has everything. Okay, so we'll see how many videos this splits into. And anything that I skip in my video, you can go check my answer key because I don't think you need me to do this entire packet because it's kind of ridiculous. Okay, so as we get started, we have two different ways to talk about the addition of functions. We can do f plus g of x like this, or we can say f of x plus g of x. They mean the same thing. If my f and g are given right here, then it's x squared, and I'm putting in order 3x, and I have a minus 2 and a plus 1, so minus 1 is my resulting function, so that is equal to one of those. The domain of that, it's just a quadratic, it's all real. And so there are no restrictions. How about we say none? Subtraction, we could write it either way here. And so if I take function f, x squared plus, so it's this. The thing to be careful about with the subtraction is that you have to distribute the negative. So then it is going to be equal to a positive x squared, a negative 3x. This becomes a positive 2 plus 1 is a positive 3. And once again, it's a parabola. There are no restrictions to the domain. On this one, so we can write it either way, f g of x or f of x times g of x. This is not the same that we will see later. We're going to talk about the composition of functions deals with f of g of x, and that's totally different. Okay, so we're multiplying the two functions, so this would be equal to, I would say, x squared plus 1 times 3x minus 2. Let's FOIL. That gives me 3x cubed. Let's do the x squared. So minus 2x squared plus 3x minus 2x squared plus 3x minus 2. The domain of a cubic function is all real. Restrictions? None. Okay, so then this one, here's the notation for when we're dividing these functions. So we have our f was the x squared plus 1. The g was 3x minus 2. There we go. There's really nothing to do. Nothing factors out. Be careful. I think nobody's really struggled with this year, but I've seen kids they'll say like x plus 6 over x, and they try and cancel out the x's, and all of math starts twitching. That's bad. That's wrong. You can't do that. If we had an x that we factored out, then you can cancel, but you can't just randomly anyway. But that has not been a problem. I haven't seen anybody try and do that this year. Okay, so domain, you are not Chuck Norris. You cannot divide by 0, so we know that this 3x minus 2 cannot equal 0. Add 2, divide by 3. X cannot equal 2/3. So the restriction is that x can't equal 2/3, I guess is what they mean by restriction. The domain is everything but that. Pick it up again, 2/3 to infinity. I ran out of space, but you get the idea. Okay, if you want to see these, you can go look at the answer key. Okay, so I do want to talk about this one because this leads into a calculus topic that's really important. And so our f was, so basically with this one, I have the function f is 1/3 times something minus 2/5 minus, and then I'm going to subtract away. So then what they want me to do is wherever there was an x, I now need to plug in x plus h. So this part right here is this right here. And now we're going to subtract away just that function, 1/3 x minus 2/5. Okay, so I have, this would be equal to 1/3, that's 1/3 x plus 1/3 h minus 2/5 minus 1/3 x plus 2/5. And now at this point we have a lot of things that cancel. We have a positive one here and a negative one there. They cancel out, a negative 2/5 and a positive 2/5. And so I'm just left with this in this problem with a 1/3 h. Super. Okay, composition of functions. We're cruising right along. Here we go. Composition, sometimes people will refer to this as fog because it kind of looks like that. But this is f of g of x. And this one over here is g of f of x. Rarely they're equal. Usually they're not. Okay, so on this one, they're giving us an f and a g, and then they're telling us to find f of g of 2. So this is going to be equal to f of, well, what do I get when I plug in 2 to g? 2 squared is 4 times 3 is 12. So f of g of 2 is equal to f of 12. Now let's come over here, plug that in, 12 plus 4, and this is equal to 16. Okay, this one is g of, plug in 1 for f, and I get 5. G of 5 is 25 times 3 is 75. I think quarters, 3/4 is 75 cents. Okay, and so now let's look at this one. If I come along, f is something plus 4, and g is 3x squared, I'm plugging that in, and actually we're done. You don't need the parentheses, but they're not wrong. So the next one, here's g. G is 3 times something squared. That something happens to be f. And that something happens to be x plus 4. And I would say clean this up a little bit. Can you see my work? There we go. This is 3 times x squared plus 8x plus 16. If you did not go as quickly as I did from here to here, then you need to write a plus or minus b squared equals a squared plus or minus 2ab plus b squared. And with a dry erase marker on your bathroom mirror, and just see this all the time. That should be second nature to you. 3x squared plus 24x plus, what is that? 18 plus 30 is 48. Okay. These get a little redundant. I don't know that we care, so let's do this one. So on this one, f of x is getting divided by g of x. And I wrote it, oh, my bad, 2x minus 5. Sorry. Okay, I wrote it this way because when we're dividing fractions, I've heard kids say keep, change, flip, so we're going to multiply by the reciprocal is what we're doing. X squared plus 1 times, when I flip this is 2x minus 5 over x. Okay, I could FOIL the numerator if I want to. Oh, be sure to list any restrictions. We can't let x equal 5/2 from here, and we can't let x equal 0 from here. If I fold this out, I would get 2x cubed minus 5x squared plus 2x minus 5 all over x. And I can't let x equal 5/2 or 0, because if I plug it in here, we have a problem. If I plug 5/2 in here, we have a problem. If I plug 0 in here, we have a problem. So this next one, I kind of liked this one. So this is, if I write out g is 1 minus 2 times something squared. That something that we're about to square is 1 minus root 3. So this is 1 minus 2 times, well, this is, we're following the same pattern right here. So 1 squared is 1. Multiply these, we have a negative root 3, but we need 2 of them, so minus 2 root 3. Square this, and I get a, but it's positive, so I get a plus 3. 1 plus 3 is 4. We have this, so this is showing all my steps. I have 4 minus 2 root 3. Distributing through, I have 1 minus 8 plus 4 root 3, which 1 minus 8 is negative 7 plus 4 root 3. I thought that would just be worth doing. This one we could go ahead, but I'm actually going to use an idea like this in a second. Okay, I want to do these last two, which are kind of extensive, but you're fine. And then I'll start the next video. Okay, so on this one, this is an idea that we need in calculus. And so what we're going to do is we're going to take, I'm going to skip the easy one. I'm going to go straight to a more interesting one. This is 2 times x plus h squared minus 3 times x plus h minus 1. And this is this initial function. And then I'm going to subtract away the original function, 2x squared minus 3x minus 1. And everybody gets divided by h. Okay, so now, I like this marker better. Okay, I have 2 times x squared plus 2xh plus h squared minus 3 times x plus h. I guess I could have distributed now. Minus 2x squared plus 3x minus 1. And everybody is still over h. Okay, this becomes 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 1 minus 2x squared plus 3x minus 1. Okay, yes, they're tedious. All over h. Now let's see who can cancel. This guy cancels with this guy. Plus 3x minus 3x, they're gone. Oh, did you catch my mistake before? Because now I'm catching it. -1 times a -1 is a +1. Okay, so this and this cancel. Here's the trick. Everybody here had better cancel. And so you noticed a second ago I had made a mistake. I didn't catch my mistake until I realized that all of these needed to cancel with something up here, and they weren't. And so that was a problem. Okay, I need more space, so I'm just going to come up here. So now I'm at 4xh. I don't know if you can see what I'm, there we go, right there. Plus 2h squared minus 3h. Did I have anything else? This, 1, 2, 3, and all that's gone. Okay, is all over h. Notice I can factor out an h, and then it'll cancel with the bottom. And so this is 4x plus 2h minus 3. And that is our final answer for this one. Okay, now here comes one that's a little bit more fun. This is an extension, but because we know Pascal's triangle, I'm going to go with it. Okay, so what we have is we have x plus h cubed plus x plus h squared plus x plus h plus 1 minus x cubed plus x squared plus x plus 1. Everybody is being divided by h. Okay, this, Pascal's triangle, x cubed plus 3x squared h plus 3hx squared plus h cubed. That right there came from this. And if you're like, oh, what the heck, Ms. Kosh, go back and find that video, because I taught it this year. This next part becomes x squared plus 2xh plus h squared. We have a plus x plus h plus 1, and then this is all minus, 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 minus. Everybody is divided by h. I will tell you, if I'm grading your work and you just stop dividing it by h, I'm going to take off points, because every line needs to be equivalent to what came before, even on this gross nasty one. Okay, so what can I cancel? This cancels with this cancels with this cancels with that, and that. Okay, did all the purple ones cancel? They sure did, so that's a good sign. And so I have 3x squared h plus 3xh squared plus h cubed plus 2xh plus, I know this is ridiculous, but we're good. We got this. And everybody is being divided by h. Notice 1, 2, 3, 4, 5, 6 terms there. They all have an h. We can factor it out of all of them, and then it'll cancel with the denominator, leaving us with 3x squared plus 3xh plus h squared plus 2x plus h plus 1. Oh my goodness. That is definitely extension, but you were up for it. All right, come back for the next video.